bisectors of the angles B and C of an isosceles triangle. So we are dealing with an isosceles triangle with AB is equal to AC intersects each other at O. Show that the external angle adjacent to angle ABC is equal to angle BOC. So first thing is diagram, because only with this I won't understand anything. I'm not joking again. It is true that I won't get to know as soon as I read the question. I don't familiarize with any question actually. It's the idea which I try to implement. It's the basic discipline that I like to learn with every problem and carry that over. So my discipline is draw a good diagram. ABC, where AB is equal to AC. Technically it has to be right. I can't just write ABC. If this was something else, I would have erased it and I would have written it. Of course, on a paper, that luxury is not there. But yeah, here it's there, so I have that sort of flexibility. Okay, so in your paper, you should always look for which sides are equal. Okay, let me mark that. And obviously, angle B will be equal to angle C. Bisectors of B and C. So we have B and C bisectors, okay, intersecting at O. What does it mean? Bisectors of an angle, what does it mean? Let me give you guys a clue, or let me show you a revision sheet. So we have your angle bisector. Please revise that if you guys don't know. Okay, I hope you guys did it. So we are drawing a line which cuts the angle into two equal halves. That's the whole idea. And it is meeting at O. Okay. We have to show that the external angle of adjacent to ABC. What does it mean? You have to think over. Again, just don't wait for me to tell. Think over, pause and think. Complete the diagram, because the diagram is the very first step. Yes, we need to extend this, right? We'll call this as, say, M. Okay. So this angle is your external angle with respect to your being adjacent to angle ABC. Right? These two are neighbors, is it not? So we have to prove that, show that the external adjacent angle to ABC is equal to angle BOC. Okay, that's your diagram. So basically we are looking at to prove angle BOC is equal to angle ABM. Okay guys, so what is the very first thing when it comes to bisectors and all of this? Proof. What is the very first thing? What do I ask you guys to do? We'll let angle ABC be equal to 2x. Okay. Yeah, before that I have to do one more thing. I forgot. I just ran into this. In triangle ABC, we have AB is equal to AC. Since we are dealing with angles, right, we have to come to a conclusion. This implies angle ABC is equal to angle BCA or ACB. Why? What is the reason? Look at the property of isosceles triangle. Yes, when we have angles opposite to equal sides are equal. Sorry, what I mean is when we have sides which are equal, the angles opposite to them will be equal. This is an example. So I'm sure you guys know this by now. Angles opposite to equal sides are equal. What is the next thing? We'll let angle ABC is equal to 2x and angle ACB will also be equal to 2x, is it not? This is as per equation 1. Okay, then what else we have? Okay, yeah, we have bisectors, no? So we'll tell angle ABO, which is equal to angle OBC, which is equal to half of ABC. by 2, which in turn is equal to x. So please pause and have a look. Just don't agree. Look where ABO is. Look where OBC is. Look where ABC is. Right? Agree? Why? The reason is BO is a bisector. Then we have angle BOC, right? Sorry, BCO, not BOC. BCO. Oh yeah, by the way, this is X. I'm trying to fill this diagram up. Think why. BCO and BCO is then, sorry, CBO. I need CBO. CBO is equal to angle BOC by 2, which is equal to X again. So this 2 is X. Agree? Reason being because OC is a bisector. Then we have what else? Then we have, yeah, I think the obvious things we have written, right guys? Now can you think of, there's actually 2 more obvious things. That is the answer actually. Can you think of it? Pause and think over. It has to do with what we have to prove. It has to do with this 2. Sorry, this is not it. To prove this is not it. We have BOC is equal to, yeah, that's correct. My bad. It's correct. It has to do with the angles which we have to prove are equal. Anything? Okay, so I'm going to show you guys. See, we have angle MBA plus angle ABC, right? There's 2 angles. Is equal to how much? Any idea? Yes, 180 degree. Why is that? We have it over here. Not there. I think lines and angles. Oh yeah, correct. Lines and angles. So they are angles on a straight line, is it not? Agree? So that's what we are looking at. This is a straight line. This is cutting. This entire angle is being cut by this line. So we have angles on a straight line. Angles on a straight line. Okay. So then we have what else? So we have angle ABC as 2x. Right. So this will become angle MBA plus 2x is equal to 180 degree. Agree? So angle MBA is equal to what? It's 180 degree minus 2x. Is it not? That's good. You know, it looks to be in terms of x. That's good, right? Getting in terms of x is what we are looking at, because the whole funda is to relate them somehow. It doesn't matter, hook or crook, you have to relate them. Now, BOC. How can I relate them to x? BOC. Any idea? I'm giving guys a clue. It has to do with this triangle. Okay, are you able to see that? It has to do with triangle BOC. BOC. Okay, so how can we make use of that? In triangle BOC, angle O plus angle OBC plus angle OCB is equal to 180 degree. Agree? Why? Simple. Yes, your angle sum property of a triangle. Angle sum property of triangle. So we have BOC and so on and so forth. We have those to be x, is it not? So this will be 2x is equal to 180 degree. So angle O is equal to 180 degree minus 2x. Agree? Satisfied? Okay. And now on to the final answer. Can you look at this? Both this expression are equal to the same value. Therefore, the final conclusion. Therefore, angle O is equal to angle MBA, since both are equal to 180 degree minus 2x. Hence proved. Yeah? Okay. Again, please see to that you understand what you're doing. Right? Understand the word bisectors. Understand the word external angle. Understand the word angle sum property of a triangle. Once you just realize that, just don't listen to it. Realize. Okay? Recall. Get familiar. Look at the same diagram every time you do a math question. Related to that. That is. So if you keep getting familiar with that, the idea will become your friend. And once the idea becomes your friend, and it's just a matter of coming to a conclusion, applying it, so on and so forth. And now your answer.